Hello, my name is Mark Hughes from the Department of Bioproducts and Biosystems at Aalto University. Along with my colleague Bahare Nasiri, we are leading the work package 4 on inventory, deconstruction and quality of recovered wood within the In Future Wood project. I'd like to share with you some background to this work package, and if you'd like to join us on the 20th of October for the seminar, then further information will be provided about the work that's ongoing within this work package. But I'd just like to give some background to this work package at this moment in time. As we know, the consumption of materials by humankind is massive. In 2019, the world consumed over 100 billion tons of materials. And a large proportion of this, in fact, about half of this material consumption was accounted for by the building sector. Unfortunately, the recycling rate is only about 8.6%, and this value has actually come down from about 9% previously. So we're actually extracting more materials and utilizing more materials, but recycling less of them, which is not an ideal situation. The building sector, as I mentioned, is responsible for about half of all materials extracted, as well as about 39% of carbon dioxide emissions and around 36% of final energy use. So the impact from the building sector is immense. This also gives us an opportunity to do something, because if we focus on this sector and try to enhance its sustainability, this could have a very, very big overall effect. We're interested in using wood as a building material because it can contribute to climate change mitigation and other sustainability goals. Wood is a good material in terms of energy efficiency and can help lead to more energy efficient buildings. It also has some good health benefits, such as helping to reduce the fluctuations in relative humidity inside buildings, which can lead to a more favorable and healthy internal climate for people. About 50% of wood is composed of carbon. So for every ton of wood utilized, around about 1 2/3 of a ton of carbon dioxide is stored within that wood material. In addition to the carbon storage capacity, when we're using wood, we are not using other materials which are often more energy intensive, materials such as concrete and steel. So we get an additional substitution improvement in terms of climate change mitigation potential by substituting for energy intensive materials. There's good potential to improve the sustainability of the built environment by increasing the total amounts of wood used in construction. And on the one side, we certainly need various mechanisms and incentives to increase the proportion of wood being used in construction. However, as we move forward, we may well be faced with supply shortages if we wish to maintain and develop the role of forests in the provision of ecosystem services, as well as providing wood materials for the growing bioeconomy. So we may have a situation where we need to improve the resource efficiency of use of wood. And this forms the background to this particular work package. So the overriding question is, how do we maximize the substitution and carbon storage benefits of wood products in construction without compromising the sequestration and sink potential of forests, as well as other ecosystem services? Something of the order of 900 million cubic meters of sawnwood and wood-based products were produced in 2018. And whilst not all of these, of course, go into construction, a large proportion do. So in effect, the carbon storage potential of the forest is transferred to the built environment, to buildings. And as buildings are constructed, the store of carbon in the buildings can increase, and this can be a source of future materials. The wood within the buildings can be a source of future materials if we learn to use this material more effectively. How much of this wood is available? Well, there have been some recent studies. For example, it's been estimated that approximately 32 million cubic meters of wood is bound up in residential buildings in Austria. And this is forecast to rise to over 50 million cubic meters by the year 2100. This study was part of an earlier Wood Wisdom Net project called Carewood. In recent work we've been conducting, we've estimated that there's around 17.5 million tons of wood in Finnish residential houses, at least there was in 2017. So we clearly know how much wood is available, and we can use various statistical approaches to calculate the amount of wood. So these studies tell us how much wood is in the built environment, but do not really tell us about the type of wood products or their dimensions or their quality. And as you can see in the two images below, on the left-hand side, it's a traditional bricks and mortar construction, but there is wood in the roof structure that could be recovered and reutilized. On the right-hand side, an image of a wooden building where, of course, there's much more wood available. But again, we don't know the dimensions of the wood that's been used, nor the quality of the wood that is in there. And this is something we really need to understand better in order to reuse it in the future. Wood can be recovered from buildings that are demolished currently, and these are a couple of images taken during the demolition of a kindergarten in Porvoo some years ago. As you can see, even buildings built with existing technologies, wood can be recovered, and this wood could be reutilized. If we look back in time to log construction, these were eminently suitable for dismantling. This is a picture of a log construction that's under storage. The logs are intact and could be reused, or they could be recycled into other products. So the structure, the original structure, the design of the structure makes it very, very suitable for deconstruction. However, what we tend to imagine and actually see in reality when we think about demolition wood is something like this. This is a picture from a waste management company. So the wood is often very broken. It's combined with other materials, plastics and metals. It's coated, has paints and varnishes and lacquers on them, or laminated with other materials. So this makes the reuse and the recycling much more challenging. For this reason, most of the wood that comes from deconstruction or demolition currently goes straight to energy recovery. So the wood is chipped and it's burned. What we would like to see, and this is the main aim of our project in Future Wood, is to retain the value or the quality of wood for a much longer period of time by reusing it or recycling it in a high value scenario before eventually recovering the energy content, perhaps with further intermediate steps in the cascade chain. However, current demolition practices are not really compatible with material recovery for cascading. So this really limits the cascading options. As we've just seen, wood that comes from buildings demolished in the current way tend to be chipped and used for energy production. So we really should think about building buildings with the ultimate disassembly in mind. So we should have buildings designed for disassembly and the recovery of elements and materials at the back of our mind always. So the aim of this particular work package is really to look at the stock of material that's currently within the existing building stock, and to understand how this relates to the wood that would actually come out of buildings. So the overall aim is to understand the volumes, dimensions, and the quality of material that could be recovered and reused, and which might be recoverable in the future if we were to implement design for deconstruction principles. So we have a number of research questions in our work package. Firstly, we would like to know what the total volume of wood is in the built environment and what it's composed of. the types of products, their dimensions and their function. And how does this vary from one type of building to another? So that's one of our research questions. We also would like to know how buildings are currently demolished, and are there any actions that can be taken to increase the recovery of high quality timber suitable for reuse or other high value applications. So it may be that there are small changes that could be made that would help us recover a far greater proportion of high value material. We also want to be able to measure the quality of recovered wood, and what criteria do we need to apply to this assessment, both within the research work we're doing, but also then in practice when we are trying to measure the quality of wood that comes from demolished or deconstructed buildings. And finally, we want to be able to predict, we need some kind of predictive model to estimate how much timber and in what form, so particularly its dimensions and its quality, is currently available and what will become available in the future, and how this might be affected if we were to adopt design for disassembly processes. So these research questions translate into our 4 tasks within this work package, which are firstly to create an inventory of wood used in construction, and this is not just at the level of volumes, but also incorporating dimensions and product types. So we need to know all about what's actually in buildings. Current demolition practices, so we are exploring the current demolition practices and how these might be modified to recover more material. In the 3rd task, we are creating a set of quality criteria for recovered wood so that we can measure the quality against certain set criteria that are relevant to the reuse and the recycling of the material. And finally, we want to create a model that enables us to predict the volumes and the quality of recoverable wood in the future. So my colleague Baha, she will give an update of where we are with the work package in the seminar on the 20th of October. So if you'd like to hear more about that, then please do follow that seminar. The expected results are to develop a model that will allow us to predict the total volumes, dimension and quality of material that becomes available. And this will help us to enable cascade options to be identified and possible implementation strategies actually developed. So with that, I'd like to thank you. Here are our contact details. Please feel free to contact either of us if you have questions regarding this work package or the work that we're doing. And of course, I would like to acknowledge the fact that, of course, we're not doing this work in isolation. All our partners are involved in this work in the In Future Wood project. So University College of Dublin, National University of Ireland, Galway, Edinburgh, Napier University, University of Ljubljana, Technical University of Madrid, the Technical University of Munich, and of course the funding agencies RISE and the industrial partners. I'd also like to acknowledge funding for Aalto's participation from the Finnish Ministry of the Environment. This is very gratefully acknowledged. So with that, I'd like to thank you and hopefully see you on the 20th of October.